In physics, every measurement of data taken is comprised of two components: the quantity of the measurement and the units being measured. The quantity is simply just the amount of something there is, like 2 boxes or 7 apples. On the other hand, units of measurements are standard instruments used to show the magnitude of a quantity. Therefore, when measuring data, we use specific instruments to find out the size of the reading in relation to the units found on the instrument. For example, a standard ruler has a maximum length of 30 centimeters. The 30 represents the quantity or size, while the centimeters represent the unit of measurement. In most cases, the type of instrument we use to make readings is important, as it can alter the units of a value. For example, if we wanted to measure the length of a single room in a house, it would be wise to use a tape measure rather than a standard rule, as the tape measure uses larger units. With the thousands of different units available for similar readings, scientists across the world have agreed on base units, or SI units, which allow for international readings to use the same unit of measurement. Currently, there are 7 base units, but in this level, we will only focus on 3. The base unit for length is meters. For time, it is seconds, and for mass, it is kilograms. Base units are really important, as every other unit of measurement can be derived from them. Now let's look at a measurement such as this. Unfortunately for us, this value can be very confusing, as it is inconvenient and inaccurate. There are 2 ways in which we can simplify this value. We could either change the notation of the quantity or change the units. The first solution is a matter of converting the value to standard notation, or as a power of 10. Standard notation, or scientific notation, is normally written in the form a times 10 to the power of n, where a is any number between 1 and 10, not including 10, and n is any whole number. For example, 2000 as a power of 10 is just 2 times 10 to the power of 3. Using this same logic, we can convert the value below to 3.52 times 10 to the power of 6. The second solution requires us to change the units used in the value. As we already know, a centimeter is a very small measurement of length. Therefore, we need to find a larger measurement to show a reasonable scale, like kilometers. For every 1 kilometer, there are 100,000 centimeters. So we divide this number by 100,000, giving us 3.52 kilometers. Now, almost every measurement in physics has an instrument to measure it, and a unit, sometimes more than one. In addition, these instruments usually have a specific way in which they are read. In this video, we are going to be explaining the basic measurements: length, mass, time, and volume. Firstly, length is the measurement of distance between 2 points along an object. It can also be considered as the distance traveled by light in a vacuum over a specific time. Length can be measured with different instrument depending on the size of the distance measured. Starting from smallest to biggest, we have the micrometer screw gauge, which can measure the thickness of paper and the diameter of metal pipes, then the vernier calipers, which can measure the depth of holes and the diameter of a pipe. Next, there are basic instruments like 30-centimeter rulers, meter rules, and tape measures, which can measure larger lengths like tables, widths of cups, and heights of cars. Secondly, mass is the quality of every object to resist a change in speed or motion from a force. In simpler terms, a mass is the amount of matter within an object, so the more the mass an object has, the harder it is to move it under a force. Measurements of mass are usually made using several types of balances, such as a beam balance, a lever balance, or a top pan balance. Some basic objects one can measure could be metals, beakers, and other lab tools. Thirdly, time is simply the measurement of duration between events. For example, the time between January the 1st and January the 2nd is 24 hours, which in seconds would be 86,400 seconds. Now, by definition, a single second is the duration it takes a cesium atom to emit this number of microwave oscillations. As obvious as it may be, time is measured using clocks and watches, either digital or analog. These time devices rely solely on the oscillation of a steady and constant pendulum. Finally, volume is the measure of space within a 3-dimensional plane. This space represents any region which is free and available. Space also represents the freeness of two-dimensional shapes like squares and triangles. This space is known as the area of a shape. Both area and volume work together as both are a result of combined or multiplied distances. For example, if we had a square with a side length of 1 centimeter, the general rule for finding the area of a square or a rectangle is multiplying the length to the width. And since all sides of a square are equal, we would say 1 centimeter times 1 centimeter, which equals 1 centimeter squared. Note that the power in the centimeters is an example of how units are derived and made homogeneous. Similarly, with volume, there is an added dimension of height that we need to consider. So, when we want to find the volume of a cube or cuboid, we need to multiply the length, the width, and the height together. Therefore, the volume of a cube with side lengths of 3 centimeters will be 27 centimeters cubed. Now, finding the area and volume of different shapes vary depending on the formulas used. You will need to memorize most of these formulas. However, others will be given to you. Here are the basic formulas to find the area and volume of common shapes.